Hello guys, welcome back to my channel. Today we are going to solve this Leetcode question, which is maximum difference between node and a ancestor. Let's go through the question now. In the question, we are given the root of a binary tree and find the maximum value v for which there exist different nodes a and b, where v is equals to a dot value minus b dot value, and a is an ancestor of b. In node A is an ancestor of B if either any child of A is equals to B or any child of A is an ancestor of B. Uh, I will try to explain this in an easy way. We're basically given a binary tree and we need to find the maximum difference between a node and its ancestor and in nodes father or grandfather or great grandfather etc. are called nodes ancestor. You you look at this example. For 3, 8 is an ancestor, and for 1, 3 and 8 both are ancestors. For 14, 10 and 8 are ancestors. If you look at 7, for 7, 6 is an ancestor, 3 is an ancestor, and 8 is an ancestor. And, uh, and for 3, and for 3, 10 is not an ancestor because an ancestor should be on the top in the same branch. An ancestor should be in the same branch, right? So he cannot be in a different branch. So for 14, what are the ancestors? They are 10 and 8, right? And if you look at this example, the ancestors of 3 are 0 and 1. What is the ancestor of 1? There is no ancestor of 1. What is the ancestor of 2? 1 is the ancestor of 2. So like that, if you got a clear idea of what an ancestor is, now let's try to understand what the problem is asking us to do. This problem, what we need to do is for every node, for every node, we need to find in the whole binary tree, we need to find the maximum difference between a node and its ancestor. If you look at this example, 1 and 8. These two are 8 is an ancestor of 1 and the difference between them is 7, right? And if you look at these two are also 8 is also an ancestor of 3, right? But the difference between them is only 5. But 7 is greater than 5, right? So 7 is our answer. And if you look at this example, you know, 10 and the ancestor is 8, right? So the difference between them is only 2. We need to take the modulus, means the absolute difference. And if you look at this node, for this node, the ancestors are 6, 3, and 8, right? The difference between 7 and 6 is 1, is not greater than 7. The difference between 7 and 3 is 4, which is not greater than 7. The difference between 7 and 8 is 1, which is not greater than 7. So the overall answer is 7 here. And if you look at this example, if you take 3, what are the ancestors of 3? 0. The difference between 3 and 0 is 3. And the another ancestor is 2, right? So the difference between 3 and 2 is 1. And there is another ancestor 1. Difference between 3 and 1 is 2. What is the maximum value from these three? Which is 3, right? So this is our answer. Let me take another example to clear clear the idea. If you look at this example, why let's solve from the top. One does not have any ancestor, right? So we cannot find the maximum difference. Let's suppose our difference is initially 0. Now you'll come to 2, and what are the ancestors of 2? Which is 1, right? So the difference between 2 and 1 is 1. Our answer will be 1. And you'll come to 5, and you see that 2 is an ancestor of 5, right? So what is the difference between 5 and 2? 3, right? Our answer will be 3. Now if you look at this carefully, 1 is also an ancestor of 5. So 5 minus 1, which will be 4. Then after completing the left part, you'll come onto the right part. You see that 3. 1 is an ancestor of 3, right? So our difference is 2, but 4 is greater than 2, right? So we'll not store this. And you'll come to 4. For 4, 3 is an ancestor and 1 is an ancestor. 4 minus 3 is 1, which is less than 4, and 4 minus 1 is 3, which is less than 4. And after that, you'll come to 6. For 6, 3 and 1 are ancestors, right? So what is the difference between 6 and 3? 3, right? So which is less than 4. And the difference between 6 and 1 is 5, right? So 5 is greater than 4. So our answer is 5. Now, if you look at this example, you do the same thing and you'll eventually find that the difference between 15 and 1 is 14, right? But difference between 16 and 1 is 15. So our answer will be 15. If you check any of them, our answer will be this, because if you find all possible answers, you'll get the values less than 15 only. Let's take another example to get a clear idea. In this example, look at this carefully. What is the ancestor of 10? There is no ancestor, right? So it will be nothing. So will not be calculating the difference. Then you'll come to 2 and you see that the difference between 10 and 2 is 8, right? So this is our maximum difference until now. Then you'll go to 4. The ancestors of 4 are 2 and 10. Difference between 4 and 2 is 2. Difference between 4 and 10 is 6. But these two are less than 8, right? So we'll not do anything. And you'll come to 6. The difference between 6 and 2 is 4. The difference between 6 and 10 is 4, which is less than 8. So we'll not do anything. And the difference between 8 and 10 is 2, which is less than 8. And the difference between 3 and 10 is 7, which is less than 8. So our answer is 8. Now I hope you got a clear idea of what the question is asking us to do. Now let's see how we can solve this question. Now let's try to solve this. What I got into my head initially, while I'm coming down, I keep track of the maximum value that I encountered. Suppose I'm at 15. Uh, till this time I have only 15, right? So the difference between my node and my ancestor is 0. Then I'll come to 10. For 10, the ancestor is only 15, right? There is only one ancestor. So the difference between them is 15 minus 10, 5. Then you'll again come to 4. When you come to 4, you have two ancestors, 10 and 15. Now you need to maximize your difference, right? You need to maximize. You need to maximize. So then will you keep 10 or 15 with you in order to maximize your answer? You definitely keep 15, right? Because so that 4 minus 10 is only 6. But 4 minus 15 is 11, right? So you'll keep track of the maximum value in order to maximize your answer. Now we'll come to 8. For 8, you have two ancestors, which is 15 and 10. Obviously, you want 15 as your ancestor in order to maximize your answer. At this point, you'll have 7. And you'll come to 2, and you see that 2 has only one ancestor, right? So for one ancestor, you have no other option than to stick with that ancestor. So the difference between the ancestor and the node is 13. We need to take the absolute value. The negative will become positive. And you'll come to 1 and you have a choice to pick or 15. You'll obviously pick 15 because you need to maximize your answer. This is our idea. We just keep track of the maximum value while going down, and for every node, we'll calculate the difference between the maximum value and the current value. But there is corner case. There is another thing we need to take care of, which is with this with this example, you get the idea. Right now you are here. Okay. If you look at this example, let's try to implement the same thing that you implemented. Come to and you that the value that your ancestor has one, and since you have only one ancestor, the difference between two is then you'll come to 5, that the maximum between 2 and 1 is, so you will take the difference between 5 minus 2, which is, but if you look at this carefully, there is an ancestor who has a value 1, and if you subtract it from the ancestor, you will get 4, the maximum value. The thing that we are doing here does not work here. So what's the trick here is we need to maintain both maximum value and minimum value. Right here we need to maintain both the maximum value and the minimum. Now, let's try to solve this by using this approach. Initially, the minimum and maximum value will be equal to the root value, which is 1, right? Now you'll come here and you have a value of 2 and your minimum is 1, maximum is also. You'll compare 2 minus 1, which is 1, and 2 minus 1, which is 1. So your answer is 1. Now you'll come here. When you come here, your minimum will stay as 1, right? 1. Your maximum is 2. And you'll compare your 5 with 5 minus 2 is 3, and your 5 minus 1 is 4. So your answer is, so like this, you'll do the same thing. You have minimum 1 and maximum 1. 3 minus 1 is 1, 3 minus 1 is 2, and 3 minus 1 is, your answer is 4. And you'll come here, your minimum is 1, but your maximum is 3 till now, right? The maximum, you'll compare with this thing. So, and when you come here, your minimum is 1 and your maximum, so 6 minus 1 is 5, right? So your answer is 5, minus 3 is, but maximum value is 5. So this is how we are going to solve this question. So the time complexity will be time complexity order of n, since we are traversing only one time entire binary tree, and the space complexity will be order of 1 since we are extras. Look at now, this is the code. Initially what we're doing is when the root is null, we're just returning 0, because we cannot, if the root itself is null, we're not having any, the root itself is null. We just we cannot find the difference, right? We'll return 0. Then we're calling the traverse function, and this function will this variable will keep track of the maximum value when this traverse function is getting executed, and at the end we're just returning this answer. Now I'll draw the I'll draw the function recursion tree so that you'll understand how the code is working. Take this. Now I will explain you with uh, recursion tree, so it will be clear for you. Suppose we have a function. Initially, our function will call this function with our root, and initially our minimum value is also 15. Your maximum value is 15. Then what you'll do? You'll call for the left subtree and you'll call for the right subtree. When you call for the left subtree, initially our answer is 0, right? Initially our answer is 0. When you call for the left subtree, function is like this. You're having a value of 10, maximum value is 15, sorry, minimum, the maximum is also 15, right? So what you'll do is you'll just find the difference between these two and these two. What's the maximum difference between these things? 5, right? So your answer will be 5. And from this function, you'll again call two other functions, which is function, the value is 4, value is, but the minimum value here changes, right? What is the minimum value between 10 and 15? 10, right? The minimum value is 10, but the maximum will remain the same, right? What is the difference between 4 and 10? It is 6. 4 and 15 is 11. So our answer becomes 11. And cannot call any other functions. Even if it calls other functions, it will become null, and they will just return there. And on the right subtree, we'll call for this 8, and our minimum will become 10, and our maximum will remain 15. Now, what is the difference between 8 and 10? Right? But our answer is 8 and 15 difference is 7. But our answer is 11. So we're not going to change anything. So we'll go back. After here, we'll here, and this function call will get executed. And you'll call function. Now you have a value of 2, and your and right here you both maximum and minimum value will be the same. So what is the difference between 2 and 15? Is 13, right? So your answer is bigger, so you'll be updating your answer. And the difference between 2 and 15 is also same. So you'll again call for the left one, but you don't have a left one here. So you'll call for null and it will directly return. You'll call for the right one. Of value is 1. The minimum value will become 2, right? Value is 2 and the maximum will remain 15. So what is the difference between 1 and 2? It is 1. But what is the difference between 1 and 15? Our answer is 14. So we'll update this answer as 14. This is how our code will be executed. Initially, if my root is null, I'm just returning 0. Then I'm just traversing this value. So look at here carefully. Initially, I'm passing my root value. This is the root I have been given, and the minimum value is also root value, and the maximum value is also root value initially. So it will go here. This is the minimum, this is the maximum, and this is the root. And what I'm doing is taking the result 1 as the difference between these two values. The result 2 is the difference between these two values. This result 1, this result 2. Result 1, result 2. And I'm taking the maximum between these three values. The answer, the result 1 and result 2, I'm storing it in answer. And when I'm calling traverse function again, I'm calling for the left subtree by passing the minimum value between the previous minimum and the current value, and I'm passing the maximum value between the current value and the maximum, already maximum value. The same thing I'm doing for the right subtree as well. And at the end, the answer will be stored in this answer. I'm returning this dot answer. That's it. If I submit the code, run execute fine. It's taking just 0 milliseconds. Yeah, that's it, guys. If you find the video helpful, just like the video. Thank you.